Good.
Okay. We're going to talk about oxygen regulators. They come in all shapes, sizes, and colors. The basics of these. Let's talk about the continuous flow regulator first. This is one that you turn it on, and it runs continuous flow until the tank's empty, or until you turn it off. These come in different variations. I don't know if you can see this. The dial here will rotate to different liter flows. There's 1, 1.5, 2, 3, 4, 5, and then a 6, 8, 10, and 15. Some regulators have a different maximum flows. So some will only go to 8. Some will only go to 4. If they're pediatric, they'll be in really tiny increments. Yeah. So there'll be like a 1/32 of a liter. Babies are really sensitive to oxygen. If they get too much, they can go blind.
Really?
Yeah. So the pediatric ones are very, very minute flows, and they have to control it really tightly. But on adult ones, where we're always dealing with adults, this one at 0.12 is really low, honestly. Half a liter, rarely will you ever use a half. It's usually 1, 1.5, or 2. This is the 90% of people will be on those. And then you got your higher flows in case they are a patient's really bad off. A couple of things on the regulator. It has a dial on here that goes to 3,000 psi. A full tank, though, is 2,000 psi. The 3,000 is reserved for life flight tanks. They're aluminum tanks wrapped with Kevlar, and they can take a much higher pressure. So they're very, very light, and they hold more oxygen. So on a life flight, you can see that that's important. Lightweight is a big deal for a life flight. So they can use that on a high pressure tank. Our tanks, though, are not built for that. They're just a 2,000 psi tank. So if someone calls you and says, "This is not a full tank, it only goes to 2,000," you're going to have to educate them like, this is a full tank at 2,000. The 3,000 is reserved for life flight type situations. So don't let them tell you that you're delivering half-empty tanks, because that a 2,000 psi tank is full. That's what it's supposed to be. Yeah. The other thing on these, the way this is designed, just for your information, inside of here is a brass disc, and that disc has different size holes drilled into it. So it's a little tiny, tiny hole for the low flows, and the bigger flows are bigger holes, so it just lets more oxygen through. They're calibrated by the pressure that this regulates. So that's all you're doing, is you're just taking a disc and moving a different size hole in front of the port, and that's what goes out the flow out of the bottom. So that's kind of explains the guts inside of these. When you're putting these on, these regulators all have a pin set index. These pins are placed in a very particular position so that they will only go on an oxygen tank. So on an oxygen tank, Shad, will you grab me a B tank there, or grab me an empty one, would you? These pins will only go on an oxygen tank. If I were somehow to get a helium tank, this reg would not go on it, because on the tank here, can you see that in the screen? Yep. This tank has 2 holes that are in the same set as these 2 pins. Now on helium, that pin is going to be moved over more toward the middle or to the side. There's 6 different positions that these pins can be in, and so it prevents you from putting oxygen reg on a helium tank. Wow. So if you're ever trying to put a regulator on a tank and those pins will not line up, do not cut those pins off and put it on. It's happened, and people have died from it. Because if you put somebody on, they need oxygen, and you put them on helium or nitrous or any other CO2, you're going to kill somebody. So those pins have to be lined up. It's a safety thing. It's like idiot-proofing the tank. If that doesn't fit, don't force it. Try another tank. Do something. And if that doesn't fit, if this tank doesn't fit the reg, this tank needs to be quarantined, and we need to inspect it for some reason. Are these pins off? Is this the right gas? Is the yoke broke? Something's wrong if this won't go in there easily. So that's a big, big problem. And again, this is going to sit on there. The easiest way to put these on is you've got to undo little T-nut there. Those pins and those holes are going to have to line up. So you're just going to put this all the way, I just let it drop all the way to the bottom, and then I'm going to push in and up, and it's going to hit those holes and slip into those. Now I just tighten this T-wrench up, and it's on there tight. Then to turn this on, these cylinder wrenches that we talked about earlier, this cylinder wrench, to pressurize the system, we turn the pressure on here. So it's got to, let me turn that down. So I'm going to pressurize this, and this tank came back to us, it's partly empty, so we're using an empty tank here, but this right now reads about 1500 PSI. So it's 3/4 of the way full. But we do not put a 3/4 of the way full tank out on a patient. It has to be full. It has to be full. We don't put a partial tank out on anybody. So now we pressurize the system, then we set the flow, and you can probably hear that. These higher flows, you can really hear that, but with the tubing on it, it muffles that, and it's much quieter. It's not that loud when you put a cannula on there. So when you're turning it off, you want to turn the flow off, turn the tank off. And actually, it's probably a little bit better if you leave that below that. There's some internal pressure. Just blow that off, and then turn everything to 0, and then it's all sealed up and ready to go. So this would be their backup or their portable if they're away, doing shopping or going out and about with family on a trip. If someone's going on a trip, you need to, they need to find out how long they're going to be, get their itinerary, where they're going to be, how many tanks will they need. You look at that little chart again and figure out how many tanks are they going to need to get, to St. George and back, if that's their trip. And so, so that's a continuous flow regulator. It's either on or off, and it works really well for most people, but because a tank this size at 2 liters is gonna go really quick.
What is it for? Or 2 hours?
It's actually an hour. I'll have to look at that chart again, but it's like an hour and 20 minutes.
Wow. On
2 liters. Is that right? I think it's about an hour and 20 minutes. So these tanks will go really quickly. So to accommodate that, because these are light and they're convenient, some people will tolerate what's called a conserving regulator. This is a whole different beast. It attaches the same way. It has the pins on there.
Does it have 3 washers on it?
This has just the one. And the other one, I didn't mention this on this other one, but all of them have this little yoke seal. They call it, it's a O washer. It's made out of brass and rubber in the middle. These will wear out over time and sometimes will fall off. You just put a new one on. But it's on that center part here that's brass. And they use brass because it's a non-ferrous material that doesn't spark. So if you're to bump it, it's not going to create a spark, which causes a chance for fire. Mm-hmm. So that little rubber yoke seal has got to be on there. If it's not, no regulator will seal. You have to have that on there for that to seal up. So this one attaches just like the 2 pins, the 2 holes, everything lines up the same. You've got the T-wrench. The difference, and the gauge is the same. The difference is this piece right here. This is designed to sense when you take a breath and deliver a large, what they call a bolus of oxygen at the first of the breath. The first of your breath, that first part of the air that you get at the beginning of your breath, that oxygen is what gets deep into your lungs and does the exchange. Later in the breath, it's all the upper respiratory tract and doesn't get absorbed. So it's just a filler. So they use this to deliver a big bolus right at the first of the breath. So you've got oxygen deep in the lungs, but the rest of it's just room air. So on your breath, as you're breathing on one of these, it pulses and it does a cht, cht sound to it. And we'll hook this up so you can hear one. We'll put a cannula on Shad here. I'll put it on me.
Oh, where?
So this is going to go in there just like the other one and tighten up. So it attaches just the exact same way as the other one. And then we're going to pressurize the tank just like we did before. So everything is exactly the same. And then we're going to take this and we're going to set this to our liter flow that we want. So there's an off position. And if I put it on 1 or any of these settings, this one goes up to 6 as the highest. But you don't hear anything flowing out of this because it won't work until you actually have somebody hooked to this and breathing, and it has a pneumatic little diaphragm in here that senses the breath and triggers that breath. So Shad's got this on now, and he's going to breathe normally through his nose. I don't know if you can hear that on the tape or not. But every time he takes a breath in, it's delivering a shot of oxygen with every inhalation. And he's right now, this is at 6 liters, so that's really pretty cranking. Now, what happens if that diaphragm in there fails? Again, respiratory things, everything's back up. So if that were to fail, there's continuous flow settings on this. So if you go past 6, you go into continuous flow. It's continuous flow CF2. So it's 2 liters. This one also has a 4 liter continuous flow.
Wow.
So if you're a heavier user, you could go to 4 or 2. So at least you have some oxygen available to you. Because if that were to break, you have no oxygen. If the pulsing device on this breaks, you're going to get no oxygen. So the idea is some is better than none is the idea with that continuous flow setting. So all these regulators, these conserving regs, have some kind of continuous flow backup. So you can get some out of it if everything else is broke on it, at least you can use continuous flow. Now the nice thing with these, if you got somebody that is using this tank, it'll triple the time on your tank. So this tank now becomes, if it's a 2-hour tank, this becomes a 6 to 7 hour tank, depending on breath rate. So if they're really quick in their breath rate, they'll use the tank up more quickly, of course. But for the most part, these will triple the life of your tanks. So if someone's using a ton of tanks and the hospice is calling and saying, "You're killing me on the price on my tank, on all my tanks. I'm going through 20 tanks a week," then trying a conserving reg like this might be the answer. A word of caution here, however, not everyone can tolerate this type of regulator. A couple of reasons. They may be a really shallow breather, and this can't pick up that negative pressure. When they breathe in, it can't pick that pressure up. So if they breathe really shallow, this may not work. If they're a mouth breather, and they don't breathe through their nose, they're just breathing through their mouth, it doesn't trigger. So these, not everyone can tolerate a conserving reg. I wish they could, because we'd put them on everybody, but not everybody can tolerate these. So don't take it upon yourself if you're delivering oxygen and they want a conserver. Don't take it upon yourself to do that without consulting with the nurse, because there's usually extra charge to the hospice for one, and then there's also the chance that this may not be a right therapy. It may not work for them. So you got to be a little careful. Just don't put this on anybody if they ask for it. It's got to be ordered by their physician or by the nurse, and don't just put it out on your own. Okay, so this is a conserving reg. This is a basic conserving reg. I'm going to show you some others that have some different features. And as this technology has come a long ways over the last 4 or 5 years, they've done a lot of new things with these. These are all through Drive. They've got multiple variations to this. This one is not pneumatic. It's based on, it has a battery in it. So it does sense the breath, but it uses electronics to deliver the right amount. It's a little more efficient. But then you add batteries to a system, and they got to replace the batteries once in a while. They do last a long time, but they're a little more sensitive as well. So say on that one we were looking at before, say they couldn't tolerate this one. These with the batteries in them are a little more sensitive to the breath. So if they can't trigger this one, maybe this one would work. Again, that's maybe.
Maybe.
But you have a little better chance if they're a shallow breather to make this work. This particular one has 2 settings here at the bottom. You have pulse and you have continuous flow, and it's at 2 liters. It's just 2 liters and done on this one. If you want in pulse, you have to turn that over, and then this button you push, and it's set at 4 liters right now. If you want to adjust that, you push and hold, and it starts to step through. So if I want it on 3, I'm just going to hold it till it goes to 3 and let off. Now it's ready to go. The nice thing with this particular one is most conserving regs will only go to 5 or 6. This one goes to 7. So it gives you a little more oxygen at that level. Most of them don't go that high, so it's something to consider. Problem, if someone's at 6 or 7 liters, they're usually not very active. So that's going to be pretty rare, but it can happen.
This one only goes to 5.
Yeah, that on the precision machine, the precision, they'll only go to 5 liters. So on this one, you can see you got 5 liters here, and then it goes to continuous 2. So you've got to watch your liter flows on these conservers. But again, most people that are going to be active and needing a conserving reg are not going to be on really high flows typically. And I say typically, there's always an exception. You'll have somebody that will break that rule. This conserver is a little different. This one it's called a smart dose system. This one will actually adjust the flow to your activity level. So if you're moving, it has a small sensor in here that if you're active and start breathing faster, then this will bump you up 2 liters more. So if you're normally at 3 liters just sitting around, but you desat when you're moving, then, and saturation is how much oxygen how saturated your oxygen levels are, then this will bump from 3 up to 5. And if you're at 5, it'll actually bump to 7. But it doesn't flag it. It doesn't on this. So right now this one's set at 5. If you can see that blinking. Yeah. Now I'm going to hold it, and we're going to let this adjust. We'll stop at 3. Now at 3, it'll pulse with each breath at 3. Now if you're active or breathing faster, it will automatically move the flow to 5, but it won't indicate that. Oh. So it's not showing them that it goes to 5, but what you're telling them is this will increase the amount of oxygen you get as you're active or your breath rate increases. So if they're at 5, they're actually getting 7 when they're active, and then it comes back down. What that does for you is, for the patient that's desats when they're active, it gives them a little more, but when they're sitting around, it cuts it back, and their tank lasts a lot longer. So again, it's the duration. These things really are duration savers. Yeah. This one has one setting for continuous flow. It's this little pin here. You pull that out, it's 2 liters. So you pull that out and it goes to continuous flow mode, and you've got 2 liters. Again, your oxygen just hooks right there. So you always have, again, all of these have some kind of a backup flow of some kind. Again, it's a battery operated system, so you got to make sure you got decent batteries in them. They do have a low battery light on there. On these with batteries, they'll have a low light that'll come on, and when that comes on, they just need to switch the batteries. Usually they're AA batteries on there. And again, this one attaches they all look different, but they attach that 2-pin system. They're on all regulators.
Are we going to supply batteries for them?
On the original one, yes. After that, they need to supply their own. Okay. So when we send them out, we should have a fresh set of batteries in them. But after that, if they need more batteries, then they can take care of that themselves. But again, a set of batteries on this lasts a long time, like months.
Oh, okay.
So it's not like they're switching this out every week. Yeah. So these are months and months that those batteries will last. Again, oxygen's a drug. It's regulated by prescription. We have to have a Class E pharmacy license, and that enables us to dispense oxygen, and that's the only drug we can dispense. But oxygen, we have to have that pharmacy license in place so we can dispense. It's renewed I think every 2 or 3 years, if I remember correctly, and we have to have that on file to hand out oxygen. This is probably a good time. We'll talk a little bit about getting too much oxygen and oxygen toxicity. Any questions on that, Chad? Anything we missed? Okay. You want to stop that for a minute?